Hello and welcome to a short video on normalization of data. We're going to discuss the first, second, and third normal forms. There are up to 6 levels of normalization, but generally speaking, data in the third normal form is considered to be sufficiently normalized for most cases of database design. Let's start by looking at what exactly is normalization. And normalization is organizing your data in the database, creating tables, establishing relationships between these tables, thus helping to reduce redundancy of data, making your data easier to analyze, as well as easier to query across tables in the database. Let's look at now some unnormalized data. And characteristic of our normalized data is the field telephone number, which you can see has more than a single value. This violates the rules of the first normal form itself, as we will see shortly. Also, there is no field that we see on screen that we can use to uniquely identify each of these rows. Let's now look at the first normal form and its rules. We can have no repeating groups across the table, and every row must be uniquely identifiable. And since we've established the fact that we do not have a field that we can use to uniquely identify each row, we've introduced a new field and called it student ID. And you can see we've separated the telephone numbers, putting each telephone number in a separate row. But this has resulted in duplication of data, violating the rules of the first normal form. We do have repeating data, as you can see, right? Also, every row in the table cannot again be uniquely identified. To resolve this, we can move the telephone numbers to a separate table. And now you can see that we have met the requirements of the first normal form. Moving on to the second normal form, these are the rules. The data must be in first normal form. All non-key fields must be dependent on the whole primary key and not part of it. Now, talking about the whole primary key, this means we have a combination of two fields making up the primary key. In the case of our tables, both of them, we just have one field that makes up that primary key, and that's student ID, and therefore the rule does not apply. We can therefore say that the student table as well as the telephone numbers table is already in second normal form. Let's now move on to the third normal form. These are the rules. The data must be in second normal form, and all non-key fields or attributes, as they are also called, must not be dependent on any other non-key field or attribute. Keeping that in mind and looking at our tables, we can say that the telephone numbers table is already in third normal form. There's no way that we can determine telephone number 2 if we know telephone number 1, right? Or vice versa. So both telephone number 1 and telephone number 2, which are the non-key fields, are dependent only on the primary key field, which is student ID. But coming to the student table now and looking at the details of the year and section. Year is dependent on student ID, but section is more dependent on year, right? So also current student count and the max students per section. What happens is if we keep this data here within the student table, what we are saying then is year is dependent on student ID, section is dependent on year. In effect, section is indirectly dependent on student ID or transitively dependent on student ID. And this is what is known as transitive dependency. It's considered bad database design because consider if you want to add a year, you can't, you have to add a student in order to add the year. Also, if you delete a student, you also delete a year. Take the teacher details now. Teacher name is dependent on the student. Student ID determines the teacher in charge of that student. But what about teacher address, teacher telephone number, teacher email ID? That's not really related to the student. Indirectly, we're saying that teacher address is dependent on student ID. That's another case of transitive dependency. If we've got to add a teacher, we can't. We've got to add the student. If we delete the student, we are also deleting the teacher. What's the resolution? We move the year details and the teacher details into a separate table of their own. Right? Now we can say that these tables are all in third normal form. Let's look at an example now where the primary key is a composite key or a combination of two fields. And I'm going directly to the second normal form because the data is similar. So we have the student table, we have the telephone number table, and these are the rules for the second normal form. The data, remember, must be in first normal form, and all non-key fields must be dependent on the whole primary key and not part of it. Now, looking at the student table, you will observe that we have a field called class ID. We could think of a candidate key being a combination of the student ID plus the class ID. But then, every non-key field must be dependent on this entire primary key, that is student ID and class ID together. So let's examine the non-key fields. Looking at student name, is it dependent only on student ID or is it dependent on student ID plus class ID? And the answer is it's dependent only on student ID. What about current student count? Is that dependent on student ID plus class ID or just on class ID? And again, current student count is dependent only on class ID. Right? And so this table is violating the rules of the second normal form. To resolve this, what do? We just move the year details into a separate table. Let's take this table forward now to its third normal form, and looking at the rules, the data must be in second normal form. All non-key fields or attributes must not be dependent on any other non-key field or attribute. And so again, looking at the student table, the telephone table, and the year details table, we can say that the telephone table and the year details or the class details table are already in third normal form. There's no way we can determine the max students per section just by knowing the current student count, right? And so both current student count and max students per section are dependent on class ID. Similarly, we've already seen why the telephone table is already in third normal form. Looking at the student table and looking at the teacher details now, we can say student ID determines teacher ID, right? Or teacher ID is dependent on student ID. Teacher name is dependent on teacher ID, right? If we know the teacher ID, we can know the teacher name, which means indirectly, teacher name is dependent on student ID. And again, we have a case of transitive dependency, which, as I said, is bad database design. The resolution, therefore, is to move the teacher details to its own table. Now all the tables are in third normal form.